In this chapter, we'll go over carboxylic acids and esters. So the general formula of the carboxylic acids is an RC double bond O and an OH. So if you're looking at the carboxylic acid functional group, that is the carbonyl that is connected to the OH. This is what makes the acid. If I want to condense it, then that is going to be an RCO2 and an H. Okay, you can also write it as an RCOO and an H. Both are right. So if I want to go ahead and draw the carboxylic acid chain of 4 carbons, all what you need to do is just count 4 carbons in there. I need it in the skeletal, so that is going to be 1, 2, 3, and the 4th carbon is the carbon of the carboxylic acid. So that is going to be the C. I can write it as a COOH, which is exactly the same as the as writing it as a carbonyl like that, and then an OH. At the end, just make sure that you have 1, 2, 3, and 4 carbons. And guys, you have to count the carbon of the carbonyl. This is one of the carbons of the chain, okay? So when you're looking at the long chain, you include the carbon of the carboxylic acid in there. Both of those are representations of the skeletal form. So if I write the carboxylic acid like this, or if I go ahead and write it as a COOH, sometimes you're going to see it as a CO2H. So, or I can write it as a CO2H. All of those are the same, and they are the representation of the condensed chain of 3 carbons in there. This is a CH2, it's a CH2, and then the CO2H in there, and that is going to be the condensed form of the 4 carbon chain carboxylic acid, and this one is the skeleton. Okay, so far when we were talking about naming of those functional groups, we've talked so far about alkenes, alkynes, these are hydrocarbons, alcohols. So I've listed the priority table. And that table, you can have it in the exam if you want. You can write it on a piece of paper and you can have it in the exam. So this is how the priority is. Your carboxylic acid are the top of the table in the priority. This means that when the acid is there, always the carbon of the carboxylic acid has to take carbon number 1. Esters are underneath carboxylic acids, but they are higher priority than aldehydes, than ketones. So this is the priority order in there. Now, how do we name carboxylic acids? As usual, we have 2 ways to name them, common and IUPAC. Common is just restricted to small carboxylic acids. If we have less than 6 carbons, then we can use common. Guys, for us, there is only 3 common names for 3 carboxylic acids that I want you to know. The first one is the chain of 1 carbon. This one is called formic acid. Form is what we use to represent 1 carbon. We talked about formaldehyde in the aldehyde chapter. So 4 is just 1 carbon, and then it depends, whatever comes after it normally represents the type of functional group that we have. So form means that I do have 1 carbon in there. Another thing that we talked about is the acid. We did that in the aldehyde and the ketone chapter, and we said that acid is 2 carbons. Okay, and again, whatever comes after the acid after the acid represents what functional group you are working with. So if it's an aldehyde, then it's going to be acid aldehyde. Then your functional group will be an aldehyde in there. Okay. Normally for common names for carboxylic acid, the name ends in ic acid. And then the last thing is the benz. So the benzo, that is going to be for the benzylic carbon. So here I am working with, this is the acid in there, and this is the benzylic carbon. The benzylic carbon, we talked about it last time. We said it's the carbon that is directly connected to the benzene. So this is considered to be a benzylic carbon, and a structure that has a benzene connected to one carbon, we call it a benz. And then whatever comes after the benz normally represents the type of the carboxylic acid that you're working with. So if it's an aldehyde, then it's going to be benzaldehyde. If it's an acid, then it's going to be we don't say benzic acid. It doesn't sound right. So this is why we introduce that O in there. And we say benzoic acid. Okay? So these are the only three that I want you to know in their common names. These are important, so please know them. The second way to name those high priority functional groups is the IUPAC name. So as usual, we're going to choose the longest carbon chain. We're going to include the functional group, but now our highest priority numbering is for the acid. And then we name the substituents as usual. So in order to name the acid, what we need to do is simply we need to drop the E in the alkane, and we need to add oic acid, not ic acid, we add oic acid. We want to differentiate the IUPAC from the common. Common ends in ic acid. IUPAC ends in oic acid. Okay, so the first thing that we do over here again is we choose the longest carbon chain that includes the carbon of the acid, because the carbon of the acid is considered to be belonging to that longer chain in there. And always I need to start my numbering from the carbon of the carboxylic acid. So that is going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. You have to know your nomenclature in there. 9 is nonane. So all what you need to do is simply write nonane. And then we are going to drop the E as in the rules, and we're going to add oic acid. So in this case, the name is going to be nonan oic acid. Okay, so it's going to be nonan oic acid, and there is a space between the oic and the acid. So make sure that you put a space in there. There is always a space between the ic and the acid. There's always a space in there. The name is 2 parts. Okay, so again over here we're going to choose the longest carbon chain that starts from the acid and include as much functional group as I can. Okay, so here I included all my functional groups. You have to pay attention that every functional group needs to have a number. And if I have 2 functional groups on the same carbon, I need to use 2 numbers representing those functional groups. If I don't, then the answer is not going to be right. Okay, so I'm going to start with the acid. This is carbon 1, 2, 3, 4, 5, 6, 7, and 8. This is a chain of octane, so it's going to be octanoic acid. So we're going to put it at the end. So it's an octanoic acid. Okay, again, there is a space between the oic and the acid. And now I'm going to start giving my substituents numbers and arranging them in alphabetical order. The chlorine comes first. So I have a chloro over here. Let's write them down for all of these substituents. So I have a chloro. This one is methoxy. And I have the 2 methyls in there. I put them in front of me so that I can arrange them in alphabetical order easily. And the NO2 is nitro. You are responsible to know the names of each and every one of these substituents. So on chloro comes first, so that is going to be 6-chloro. On carbon number 3, I have a methoxy. So that is going to be a methoxy. And then on carbon number 2, two of them, I have dimethyl. It's a dimethyl. Most of you are forgetting the prefix, which is di. This is important. If you forget the prefix, this means that you forgot a substituent and your answer is not right. Okay. And on carbon number 8, I do have nitro. And then it's one word in there. It's an octanoic, and then space, and then an acid. Okay. Now there's a big difference between a benz, which is a benzene connected to a carbon, and the cyclohexane that is connected to a carbon. Benzoic acid, by the way, is used as both as IUPAC and as common. So you can go ahead and put this as a note that benzoic acid, this one is used as both common and IUPAC. Okay, so the name will be the same thing. If I want to name it in IUPAC, it's going to be benzoic acid as well. For a cyclohexane, I cannot name it as benz anymore because it is not a benzene, it is a cyclohexane. So the rule says that if you have a cycle and there is one carbon pointing out of the cycle, see, there is one carbon in here, this is a one carbon in there, so that carbon, I'm going to call it carb. And the ending in there, it's going to be an oxalic acid. So that is going to be a carboxylic. So I'm going to name it as a carb, oxalic, and then acid in there. Okay. It's going to be a carboxylic acid. And of course, I do have here a substituent. Notice the acid is a very high priority, and it's higher priority than the cycle. This is an alkane after all. So alkanes cannot come at the end. Alkanes have to be now substituents of that one carbon. Even though they have more numbers, they are not functional groups. So now my substituent is going to be a cyclohexane. So I'm going to name it as a cyclohexane. And it's going to be a carboxylic acid. So it's going to be a cyclohexane carboxylic acid. You can leave a space between the cyclohexane and the carboxylic acid, or you can put them together. It's not a big deal, but just make sure that you leave a space between the carboxylic and the acid. You have to take into consideration every single functional group in there in your chain, even though your chain is not going to be the longest carbon chain. So here, for example, see, I do have an acid as a functional group, and I have an alkene as a functional group. So now my chain has to include both. The alkane is not a functional group. Even though if I go this way, it will be longer than going this way. But still, I am going to go ahead, and this is 1, 2, 3, and 4. 3, 4, and 5. So going the other way is going to be 5 carbons. Going this way is going to be 4 carbons. I'm still going to choose this way because I want to include as much functional groups as I can. Okay, so I'm going to start numbering from the acid every single time because this is going to be my highest priority. This is a 3. And that is going to be 4. It's a chain of 4 carbons, so it's going to be butanoic acid. But on carbon number 3, I have a double bond. So the name now, it's going to be, instead of a butane, it's going to be butan. I have to include the En, so that is going to be butan in there. So this is an indication that I have a double bond. Where is the double bond? It's on carbon number 3. So that is going to be 3-butan. And then I'm going to add the oic, space, and an acid in there. So I've named actually my acid, and I have named my double bond, and I have named my parent chain, which is 4 carbons in there. All I need to do now is go ahead and name my my alkane, which is now a substituent. So this guy over here belongs to carbon number 2. So, and it is 3 carbons. See, it is 1, 2, and 3 carbons. So that is going to be 3 propyl. I'm sorry, 2 propyl, because it is on carbon number 2. So that's going to be 2 propyl, okay, and the 3 butanoic acid. Whenever I have a benzene and I have 2 substituents on the benzene, okay, then I'm going to use the ortho, the meta, and the para. Remember the common root. The acid is a higher priority than the methyl, so instead of naming this toluene, I name it benzoic acid. So I'm going to go ahead and choose my common root, which includes the acid and the benzene, and that's going to be at the end. It's going to be benzoic acid. Okay, and then my CH3 is on the second carbon, that is ortho. So it's going to be ortho methyl benzoic acid, and that is going to be just one word in there. So it's going to be ortho methyl benzoic, and then you have, of course, a space, and then the acid in there. You could have said 2, not 1, 2, because the benzoic is always at 1. You don't mention that because it's a common root in there. So you mention it as 2 methyl benzoic acid. Okay, either or, which one we prefer? Of course, we prefer the ortho. Here we do have the benzoic. We do have the alcohol in there. We said the alcohol is called hydroxy if it is not a high priority. If it's a substituent, the OH is a hydroxy in this case. So that OH, we're going to call it a hydroxy. Okay. And then the common root here is what? It is the benzoic acid, because the benzoic acid is a higher priority than the phenol. So this is why the ending is going to be in benzoic acid. That is a para. It's a 1,4 substituent in there. So that is 1. You start from the acid, and the OH is on 4. So I would say this as a para hydroxy. Okay, it's a hydroxy, not hydroxyl. It's a hydroxy. And then bring the benz all the way here. Let me erase and put the benz there. OIC, and then acid. Or I can name it as 4-hydroxy benzoic acid. Whatever you want, but we prefer the ortho, the meta, and the para.